All right, this is the last one, round robin scheduling. Again, I'll say again that these scheduling algorithms can be combined with each other and so on. Now with round robin scheduling, it implements FCFS or it might implement SGF, but then what round robin does is it also has a quantum time. Now that is what sets round robin scheduling algorithm apart. Now, if you have a quantum time and then you implement SGF or FCFS, it is known as round robin scheduling. So let's implement FCFS, meaning first come first serve, meaning we'll run P1 then P2 then P3, but with round robin scheduling rules. Now, with round robin scheduling rules, we have to choose a quantum time, and in this case, we have chosen 4. In some algorithms, in our system it might be 10 milliseconds, 100 milliseconds, but for our case let's choose 4, meaning no matter how long a process is, it will not get the CPU for more than 4 milliseconds. It gets a CPU for 4 milliseconds, but then it gets preempted so that the next process gets the CPU. All right, so this is also an algorithm which implements preemption. So let's start. P1 needs 24 milliseconds, so we will run 1, 2, 3, 4. But again, round robin does not allow any process to run for more than 4 milliseconds, so P1 is preempted. So we can put here again that finish time, right? So P1 ran for 4, now it's 20 milliseconds left. Next, P2 runs, so it runs for 1, 2, 3, even though it still has the CPU if it needs, but then it does not need the CPU anymore, so it stops. Next, P3 gets the CPU, 1, 2, 3 again. If it needed the CPU for a longer period, it would have gotten it, but then it does not need it. So now P2 done, P3 done. Now it'll go back to P1. Now again, it will give the CPU to P1 for 1, 2, 3, 4 milliseconds. Stop. Right? Because it cannot get the CPU for more than 4 milliseconds. But then at this time, according to our queue here, there's no other process, so it will not go to another process, so it will give P1 another run. 1, 2, 3, 4. Again, we keep on minusing here from this 20, and again it'll run 1, 2, 3, 4, and again 1, 2, 3, 4, and so on until P1 finishes. Now we do not need to show well P1 finishes because we're calculating the average waiting time, so we just need these points. In fact, we don't need these points behind here. So if you calculate the average waiting time for P1, at first it was 0 because at first it got the CPU, right? But then at 4 milliseconds it got preempted by the quantum time, not because of arrival or anything, but by the quantum time. And then it got the CPU again at 10 milliseconds. So we have to find out this space. We can find that out by minusing this and this. So it will be 1, 2, 3, 4, 5, 6 milliseconds. So 0 plus 6 milliseconds, right? Plus P2 had to wait 4 milliseconds. P3 had to wait 7 milliseconds, right? The three of them divide by 3, so this gives me 17 by 3, which when calculated this will give me 5.66 milliseconds. Alright, so that is the average waiting time of this process. Now you can ask me, so P1 was preempted 1, 2, 3, 4, 5, 6 times, but how come we are adding only 2 of its waiting time? That's because first here It did not wait. It did not have to wait. It got the CPU. It's actually only here where it had to wait. So it's between just, in fact, only this amount of time, as you can see, was not given to P1. Otherwise, all of this is occupied by P1. Even here, when the quantum time is done, still it got to continue because there are no more processes in the queue. Right, so this is round robin scheduling.